Hi guys, it's nice to see you again and welcome to this lecture about solving the exercises of section 1.1 of the first chapter of the famous book Thomas Calculus. Today we're going to solve exercises number 7 and number 8. Exercise number 7 and number 8, which of the graphs Exercise number 7 and number 8 says which of the graphs are functions and which are not. In exercise number 7 we have two graphs. In the book we have a graph A and we have the graph B. Both these two graphs belongs to exercise number 7. This is A and this is B. Exercise number 8, we have this graph and this is A, and we have the other graph which is B. We have an ellipse. It's very easy exercises, and he wants us to find, or he wants us to indicate which a graph of these graphs represent a function and which one is not. So what we're going to do, we're going to perform the test of a vertical line. So we will scan a vertical line, starts from the beginning of the graph of the function all the way to the right, and we can see easily that when we pass this point to this graph, we will see that this line will cut or intersect with the graph in 2 points. That means that we have some element x in the domain, and this x has two y's, has this y, for example, let's say y1 and y2. So this will violate the condition of the function. That means we can see that one element in the domain connected with two elements in the range. So that this is not function. This is not function. Now we have the other, sorry, it's B. We have the other graph, and also we're going to do the vertical line test. Imagine that we have this chalk as a line, vertical line, and we will pass it here. When we pass it from the left to the all the way to the right, we can see that in every position here, in every position, in every step to the right, we can see that this line intersects with the graph with just 1 point. See, you can easily see it's just 1 point and to the end of the function. So we can see that this is function. Okay, and we can come to the exercise number 8, and we can perform same test, which is the vertical line. We can say, for example, if we assign a point x here, we can that x has 3 points, y1, y2, y3. That means the vertical line intersects with the graph in 2 points, and that's violate the condition of the function. So this is not function. Okay, and this is also when we do the vertical line test, we can see that this x here send us two distinct y1, two distinct or two different points two different y's, and that makes it not function. So we can see that this is the only case where the graph represents a function, and these three cases are not functions. So we're done with the exercise number 7 and exercise number 8, and we found out that these are not functions. So now we are in the section of finding formulas for the function. So we have a certain functions and we need to make a formula. The first solution of number 9, express the area and perimeter of an equilateral triangle as a function of the triangle's side length x. I assume that you all know that equilateral triangle, it's a triangle that has three sides with the same length. Okay, so he wants us to express the area. That means he wants me to express the area A, that I wanted to express it as a function which is depend on the element x, and he wants me also to express the area and the perimeter. That means P, he wants me to express it also as a function g of x. So he wants me to express the area and the perimeter as a function that depends on the variable x. So what I'm going to do right now, so he wants me to express them, the area and perimeter, as a function that depends on the x, which is mean the side of the equilateral triangle. So what I'm going to say right now, we have a law, because I don't want to derive it here, that the area of this triangle is the square root 3 on 4x. I don't want to derive it here because it's not the subject. I don't need to derive it here. Just I wanted to bring it here, that and we all know that the perimeter is just the sum of these three sides. So x plus x plus x should be 3x. Okay, it's too easy and it's straightforward, and we can see right now that we wrote a as x p to 4, and we wrote p depends on the variable x, which is a 3. So we expressed the area as a function of x and expressed the perimeter as a function of x, which is the length of the side of the equilateral triangle. Triangle, I don't know. Now we have exercise number 10. Express the side length of a square as a function of the length of d. So we have a square, and we assume that the sides are all x, and we have something called diagonal. Okay, this one, and it has the same length. So this one is called d, and this is equal to this diagonal, equal to this diagonal. So it's d, doesn't matter. He asks us to express the side length of a square as a function of the length d of a square's diagonal. Okay, then express the area as a function of d. So he wants me to write the length of side, which is x, as a function of d, and he wants me to write the area also as a function of the variable d. Okay, so I need to write the length of the side of the square as a function of d, distance d. I need to write also the area of the square as a function of the variable d. It's not a variable, but just expression. First, I need to find d. As we know, if I take this triangle here, This is a triangle here, and it has a corner here, an angle, not a corner, with 90 degree. So I can say that this length squared plus this length squared equal to this length squared, which is Pythagorean theory. So, or relation. So x squared plus x squared equal to d squared. That means d squared equal to 2x squared. Okay? So I need to express x. So both x and d are positive because they represent just length. So I'm going to say by square root both sides, I'm going to say d equal to the square root to 2 equal to x. I don't need to put absolute value because both values are positive. So x will be, I will divide it by d on the square root of 2. I can see right now that I expressed x as the I expressed the x as a dependent variable and d as independent variable. So I expressed the length side x as a function that depends on the d, which is the diagonal of the square. What I'm going to do right now also, I'm going to express the area of the square as a function of d. So a will be x squared, that means x multiplied by x. So x equal to d, that means a equal to d squared, which is same the value because x equal to d divided by square root of 2. So I'm going to say d divided by squared. So a equal to 1 by 2 d squared. So now I expressed here in this step, I expressed a as a function that depends on the variable d.